Okay, so this is my most efficient way to give the lecture, to write down something, right, and also to have a recording. Okay, this about the examination and some background. Background is just to show off, right? Just to show when complete this subject, right? When you have such kind of skill, what can you do? Actually, it is a professional and fundamental subject. Sometimes it has the potential of utilization, and sometimes you do not use it directly. Just like mathematics, right? Mathematics are everywhere, but it's hard to see at the specific situation, right? What kind of mathematical theory we use in this situation. It's similar to dynamics vibrations. Okay, in those jobs, right? And you will use this knowledge and skill in dynamics to know how to read other advanced materials. Okay. Also, in your FYP, final year project, right? So you will also use some of the dynamics knowledge to do the simulation or to write on your essay or report. So the first part is dynamics. So in dynamics, what are we gonna do? We talk about three things. No matter how complex a system is, all three things we talk about in dynamics are listed here: speed and velocity, acceleration, force and moment, or also work, right? And the extended concept. So we will ask for this movement, speed, velocity, or position, right? Or position. So can we control the robotic arm precisely? If it's not precise, right? And how to optimize this structure. Also, for such a structure, when we want this specific arm or specific finger to a position, to a preset position. So when operate such a robotic structure, what is the acceleration of each part? Why we consider about the acceleration? Because it is about the dynamics loading. Dynamic loading. So when we consider the dynamic loading, we consider the internal or external force in this structure, right? Not just the robotic arm, but also you see the airplane, other machine, right? Or motorbike, or a trunk, a gearbox, right? Everything when it moves, we will talk about the dynamic properties of such a system. So as long as your design has a movement, we need to consider its dynamic system, a dynamic problem. Actually, this is also a software, and it has a student version, and you can visit this this link to download and try, and you will know some aspects of dynamics application. It's developed by Korean. Okay. Actually, we always use American software, right? And Europe software, such as SolidWorks, right? And the CATIA and the MATLAB, right? And the ANSYS. They are all from Western, and this software is from Korea, and very famous in our field. Okay, the second topic of this subject is about vibrations. Vibrations actually is also dynamics, because this aspect is very huge and very systematic. So we just put them out as another system and call it a vibration problem. Just a periodic dynamic problem. Okay, pendulum, and even rotation, right? As long as it's a period. And also the vibration shown here, right? The airplane vibration, also the vibration of robotic arm, right? As long as it's about it moves back and forth, right? In period. 往复运动啊，因为这个 branch 它太大了，我们可以把它叫做 dynamic problem， 但是呢，由于它太大了 ，it too big， 而且又很系统，所以我们单独把它拿出来叫做 vibration。As this part is very systematic, we can see when we study this kind of problem, we consider the frequency. What is frequency? Frequency is how frequent it moves. For vibration, it moves back and forth, right? For one period, okay, one period, move forward, backward for such a period. How long will it take, right? And given 1 second, how many periods it moves? We call it a frequency. And frequency is the item to describe many things, such as our electricity supply, right? And you can see it is 50 hertz, right? 50 Hz on our socket. You can see that. It means the electricity, right, supply has also has its own frequency of vibration, because it change. Because it is alternate, right? AC power, alternate circuit, right? And the positive and negative just has a loop, and it has it loop 50 times each second, right? So frequency is everywhere. Also, the frequency of sound, right? Sound is also my research field. And you visit my Google Scholar, you can see so many acoustic and sound related research. So we use low frequency to describe a low voice, right? We use a high frequency to describe the high voice, the tone, right? So it's very important concept. So as I said, this is a very fundamental topic, right? Fundamental subject. We can use our concept to different field, different aspects. Okay, so do not limit these words or this concept to our own course, our own subject. We can apply it to other circumstances, okay? Other conditions. And if you are interested to attend a student program or research program, even in your FYP, and you can come to me and to know more about the vibration and sound. Yeah, now I'm constructing a vibration platform to see the propagation of the elastic waves. So it is also about vibration. Also, we talk about the mode. Mode is about the fundamental behavior of waves or of the vibrations. And I just keep it here, and later we will go in detail. So we will ask ourselves about those aspects. In this vibration, what's the maximum displacement? What is the maximum velocity or acceleration or stress? When we know these things, we can write specs, right? Specifications for the device, right? Because when, as an engineer, you will develop products, right? After developing, and there are so many criteria or specs you need to give out, right? So if at a specific utilization condition, okay, what is the maximum displacement if it vibrates? And can the single part inside bear the loading of the maximum stress, right? You need to verify, you need to have an experiment or simulation to validate those specs. When you purchase something, right, you apply for money, right, as a project manager, and you will give others the specific specs you want to use, right, for equipment. And those things, together with the dynamic, right, dynamic words, are the main specs you need to consider for a mechanical system. Okay. This is the utilization of vibrations. This is the Guangzhou Tower. Last year I went there, and I saw the control room of that tower. It's a very big plant to control the vibration, and you can see the observation of this tower's wave, right? And the tower on the top lid, it has a observation all the time. Also, another kind of vibration is our heartbeat, right? Beat per minute is 71, right? Seems this person is healthy, right? Based on the heartbeat. And actually, you can develop such kind of small things with just very affordable MCUs, such as Arduino, right, or STM32, right, and or other MCUs, or Raspberry Pi, right, and you can after class you can search those MCUs. Yeah, that's the Juno, right, or Raspberry Pi, or STM32, right? And with these MCU boards, together with sensors such as accelerometer, right? And you can measure. You can do some measurement and to measure the dynamic properties such as the accelerations or the positions, right? And yeah, I'll give it here because maybe you will use it in your student project, and After that, you can come back to see whether kind of tools you can use for your project. 给你们帮助你们扩展一下兴趣，说怎么把我们学的东西跟现实的应用结合起来。你可以自己如果感兴趣的话，可以做一些这样的手工。Okay, another one is about the detection and the monitoring, right, of the health of a very huge constructions such as a bridge and some landmark buildings, and we always monitor its vibration property to see it's healthy or not. The second. Something unexpected happens. Okay, continue. For the textbook, we mainly use this one, Dynamics by Hibler. And you can download it from Google. And I can also share to you to the Blackboard. Okay, it's totally legal, right? Because in our library storage, we have the copyright of this book. So I can share it to you. Also, I can share your other textbooks, and later you will see it tomorrow. Okay, this evening I will upload these textbooks. You can find the PDF, okay, of those books. And actually, those textbooks is not for a single semester. You can see it covers a very wide range of dynamics, from dynamics particles to the dynamic rigid bodies. Actually, we only consider the dynamics of rigid bodies because you have learned it of the dynamics from particles in HPCC or the lectures in the same level. I mean the fundamental mechanics and or engineering mechanics, and you have learned some particle dynamics. But for some of you, maybe after you learn it, you just return it to your previous teacher, right? So I can't remember. Okay, so I just put 12th chapter 12 into our subject. So when necessary, I will give you have a minor revision of those knowledge and skill, because we'll use it frequently in the later chapters. Okay, so what we talk about is those chapters from 16 to 22. 16 and 17 is about kinematics, or 16 is about kinematics, sorry, and 17 to 21 is about kinetics. Actually, we just talk about we just expand from 17 to 19, because 20 and 21 is just a generalization in 3 dimensions, in 3D space. It just increase the complexity of the problem, but there's no new things. Okay, we just focus on this one, and this one. But for 22, you see, they're just a single chapter, but do not underestimate this part. Okay, even it's just one chapter, and you know, sometimes things, the amount of the things, especially in mathematics related subjects, is not what it looks like. OK，什么意思？你不要看它只有一个 chapter 啊，觉得它东西很少，不是这样子的。你把它展开的话，它可以包含很多东西的。这是 O2，像那个 examination paper，我是最喜欢出 3O2 这样的题目。为什么？I just need to have 2 to 3 sentences, but you need 1 page to complete the answer, right? Because you need to analyze. The same thing for the vibration. Although it just have one word, vibrations, actually when we expand it, it has a very different cases and topics. Right? For example, free vibration and forced vibration. Right? In free vibration, we have free vibration without damping. And when free vibration with damping, we have a heavy damping, right? And under damped system. So in forced vibration, we also consider without damping and with damping, right? So when we expand it, there's many topics, different topics, and later you can try to read those textbook to see the variety of the vibrations. Okay, and our teaching plan. I'll use 4 plus 4 plus 4 weeks, right? 4 plus 4 plus 4. And first 4 weeks, we talk about the kinematics. Kinematics means how things move. And kinetics means not only move, but also the interactions. Interactions means the forces or the work. Sorry, ORK, and energy, right? Work energy, and even the momentum, right? Pulsar momentum. But we will just focus on these 3. And if we have some time, I will give you a further explanation of other topics. And last 4 week, we will talk about the vibrations. And for the assessment, we have a continuous assessment and examination. Examination weighs 50%. Okay, 50%. And for the continuous assessment, and we have another 50. And there are 3 assignments. Assignment 1, 2, and 3. You can see assignment 1 is 5%, 2 also 5%, because they both belongs to dynamics part. And for the vibration part, we have 1 more assignment with 10%. Okay, so for the assignment, totally, there are 20%. And at week 7, we will have a class test. And this class test cover the planar kinematics. Okay, so if you got this message, do not come to ask me about this question. So what is the coverage of the class test? 考到哪里啊？就前4周学的内容，但前4周学不完。我指的是 planar kinematics， 不是指的前4周。OK， sometimes we need 1 more week to complete the to complete the planar kinematics. So I just would like to ensure, okay, the coverage of the test is only about the planar kinematics. Okay, planar kinematics. kinematics 啊，运动学部分啊，繁体字怎么写？运动，哎，运动好，哎。So not about kinetics. Okay, kinetics means 动 like 好啊，跟动力学没关系啊，我们只考运动学的部分啊，test. And yeah, so one assignment about the vibration, and then the last 15 is about the lab report. Lab report, you will have a laboratory session in vibration. And that session is 30 minutes. Okay. And there will be a 5 people group. Okay. And you will have this session group by group. And before week 4, I will give you the timetable. So you do the attend the lab session group by group. For example, student A, B, C, D, E. Okay, from maybe at Saturday. Okay, from 9 to 9:30. Okay, you have 10 this lab session, and you got the data, right? And when you come back, these 5 students share this group of data and write your report individually. Okay, it means you analyze, okay, in same group, you analyze same set of data, but you write your own report. Okay, you need to do maybe you need to do the coding, do the interpretation of the data, and the write report, do the review. You do it individually, and because there are 5 people in your group, I will receive 5 lab reports. Okay, each report is just from 1 student. This is required by HKIE, and this is more fair. So actually, at the beginning, in the early years when I teach here, actually you just submit a group report. But sometimes we have free rider, and they can avoid. Okay, so much about the teaching and assessment plan. Do you have any question? 有冇問題？冇啊，係，但係 report 係 individual 嘅，自己寫自己嘅 report，唔係 teamwork。嗰個lab session planning 係嗰個 operation 係 teamwork，攞嗰個 data 係 teamwork，但係攞到嗰個 data 之後，你寫 report，你做 analysis 係自己嘅嘢。Okay, any other questions? 係啦，唔係50，望一望，係咪55？ Okay, then the lab report should be 10%. I forgot to update. Is it correct now? Week 8 and week 9, as I remember. I'm waiting for the final confirmation from the office. After I got the final timetable, I will update to the Blackboard. Okay, I will update everything to the Blackboard. Okay, so you can check the Blackboard for everything about our lecture, of course. Any other question? You mean the test? Oh, the exam. Exam. It is at the end of the semester. Everyone to get examinations, right? Oh yeah, the two. Yeah, class only two. Yeah. You want to have more?
I mean, if we have to write any assessment.
You mean quiz-like things? Okay. So for the CA, we just have one test, and it will 20%. Oh, every test and examination, they're all closed book, but you will be provided a sheet with the necessary equation formula on it. Okay. No need to remember everything. Okay, so I mean the difficulties of these subjects not memorizing. Okay, it's about analyzing. Okay, last part of this hour is the roadmap of learning. So I just list the keyword of the three parts, and following this roadmap, you can check the necessary knowledge skill and for you to pass the assessment, or to check whether you have understand the tree of this or the structure of this subject. Okay, so you can have a break tour. Okay, let's move on. One more thing about for the student who are not in the classroom. This is my WhatsApp, official WhatsApp. And so by using this number, you can send questions for consultation about this subject. Okay, so let's come to the content of this subject. As you can see from here, we have chapters about this roadmap, and in chapter 1, we talk about those things: the preparation of kinematics. Actually, it's about the rotation of rigid bodies. Maybe if you have learned it, maybe you find it very simple, and I would like to congratulations to you, right? Because most of you maybe have already forgot those parts, and for this chapter, we aim at constructing a new way to describe the motion in an effective way. Okay, so in this chapter, you will learn how to describe rotations. Okay. And it's about their displacement, velocity, and acceleration in rotations. And another thing, you get familiar with vectors and vector basis, and it's their basis. In Cartesian, we always use I, J, and K. I, J, and K, right? 3 bases in X, Y, and Z direction. So from this lecture, everything will go with vectors. So when given a vector, we give its magnitude and direction. So we also have a vector calculation, right? And you're gonna be familiar with a vector and its calculation. As you can see, everything in this chapter, we have a arrowhead on it, right? Because we consider not only how fast, but also the direction of that speed, or direction of the acceleration, or the displacement. Okay, pay more attention to the vectors. And if you have forgot the basics of vectors, you can come to the textbook, this textbook. At the end of this textbook, there's an appendix about the mathematical tools for the vectors. And you can have a quick revision of that part of the knowledge. Okay, so before we start, maybe I need to go in detail to have a brief introduction of the whole structure. So why we call it a tree? It means for the rigid body, okay, rigid body, it has motion, right? It has motion, and because it is not a point, right? Because it is not a point, and the motion, it has two components. One is rotation component. The other is translation component. I mean, the angle change and the position change, right? No matter which one happened, okay, no matter rotation or translation, it will change the position or speed of a particle on it, right? So from a rigid body and its rotation and translation, you can calculate the motion of a particle on it. We call it particle velocity or particle acceleration. Okay, and you can tell apart these two different things. Okay, one is about rigid body, the other is about the particle. You need to link up them. Okay, and to solve this problem, we're gonna use a method called relative motion analysis. Okay, relative motion. So with respect to a specific already known particle, okay, we calculate the unknown particles motion properties. Okay, we call it the relative motion analysis. This is the most essential part. Okay. So for this part, we have 4 main structures. And as we move on, you will know these typical structures. Okay. And the comprehensive questions is very easy to get because we can just pick out one specific structure and let you to analyze its relative motion to find out the particle velocity or particle accelerations. Okay, this is a typical analysis way. Okay. Okay, we start from the kinematics 运动学。那讲运动呢，那就是从这一个 chapter 开始。Okay. So we talk about some prerequisites as highlight here, and kinematic quantities and of particle motion and their representation. Okay. So at the very beginning here, you will see some something you're familiar with, because they are all about particles. Okay, particles. It's all about a point for a specific point, and what is their velocity and displacement and acceleration. And then we expanded to rotation. Okay, we start from very fundamental things, displacement. So what is the displacement? It shows a motion from one point to another point. I mean, from the initial point to the terminal point, right? So the change of position. Change in position. Everything, because it's mechanics, and it has a very strong mathematical background. So everything will be defined strictly. Okay. It's very rigorous. So when we talk about the displacement, it is defined as the change in position. So how to describe what is the position, right? For each word, you can ask what is, right? What is the position? Position, we can describe it with coordinates, right? Coordinates. Maybe give in the maybe 2D or 3D, even 1D coordinate. If we give the coordinates of a specific part, the specific point, and we can link it with a particle's position, right? Just as here, we have a s-axis, right? This is a one-dimensional axis. In this axis, based on this axis, we can talk about position, right? At the beginning, the position is at S. This S can be a number, right? S can be a number. For example, it is 10, and the unit is a meter, okay? And S prime can also be a number, right? S prime can also be a number. It's also maybe 12, right? Also in meter. And how to find the displacement, right? So from the, because we call it the change in position. Change means terminal minus initial, okay? Change means terminal minus initial. 一定是后面的减去前面的，那才叫 change. Change of temperature. Okay, so 10 minutes, right? In 10 minutes, so use the later one minus the previous one. Okay, when you move this concept to other regime, same thing. Okay, the later one minus the former one, we call it change. So change in position, we find sometimes it's positive, sometimes it is negative, right? If S prime, right? If we have S prime, maybe, right? Another position after S prime, maybe it is 8 meter, right? If we have S prime here as 8 meter, right? As here, right? S prime prime, a meter, and we can find sometimes it's positive, right? I mean the change of position. So 12 minus 10 is positive. Sometimes negative, right? 8 minus 12, or 10 minus 12, or 8 minus 10, right? So positive and negative indicates its direction, right? We see for displacement 1, you see from S to S prime, it can be this one, right? This is the end point, right? This is the initial point, right? And initial point is in the left, and the end point is on the right. So end minus initial is a point to the right, right? And if it is negative, for example, 8 minus 12, 8 minus 12, it can be from here, right, to here, right? This is the new end point, and this is the new initial point. From this new initial point to this new end point, you just like move like this. I use the red one, okay? The new initial, new end, and it moves to the left. So here, 8 minus 12, it is a negative 4. Negative 4 means to the left. Okay. It doesn't matter if we just have one dimensional coordinate system, but we have two. If we have x direction and y direction, we cannot just use positive or negative to describe the direction, right? And the three-dimensional space also, right? We face this difficulty. We cannot just simply use positive or negative. So how to deal with this thing? We just use a symbol to describe it. Well, here, delta S, right? Delta S is the displacement. We call this displacement. If we use vector, we can do it like this. So this displacement is 2 meters, right? And we can use 2 meters to show the magnitude, right? We call it a magnitude, 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 大小, okay? And we also need to point out its direction. So direction is from left to the right. So we have such a conservation to the right. We just use a small arrow to the right. Okay. And for the other one, we have S prime, delta S prime, okay, delta or delta S1. It's 8 minus 12. It's negative 4 meters, right? We do not write negative here. We just put 4 meters here because it's also a magnitude. There's no negative magnitude. Okay, make it look comfortable, right? There's no negative magnitude. All magnitude are positive or zero. Okay, not negative. 这个后面我会经常用到，你们明年还会见到我们还会讨论 magnitude. There's no negative thing here, okay? And for the direction, it is a one dimensional, right? We just use a left pointed arrow, right? Left pointed arrow. 这样就可以了。So it's very simple, very simple. Even in 2D, you can do it like this, okay? For example, we have 2 meter displacement, and maybe I just put it here in such X and Y, okay? It moves, start from here, from the O point, and 2 meter from O to such a point, and we know this is 45 degrees. And from the textbook, you can see such kind of a description. It has a 2 meter here, okay? And it's not horizontal, neither vertical. It's horizontal plus vertical, right? So we just draw a incline arrow here and tell the audience the angle of such displacement, of such a displacement. So this is one type of description. Okay, 这边也是。在你们 assignment 还有考试里面也可以这样去写 ，OK？In your in your student work, you can write like this. Okay? So, firstly, the magnitude. Secondly, the direction. It's the most directed one, right? It's a straightforward one. You can find it at the first glance. You read it. It is convenient for us to write down such a or understand such a symbol, but it's not easy for us to calculate. So we have the other way to describe it. And we have such a conservation. I need to here. So we have a conservation. Okay, we call it vector conservation. Okay, vector method. When we can use a vector to describe such kind of motion. So how to do it? And we name 3 vector bases. I means one unit. Okay, it can be meter, it can be meter per second, it can be millimeter. Okay, so it is 1 unit, any unit along positive x direction. And you will know negative I is also 1 unit along negative x direction. Once we have I and negative I, and this delta S and delta S1 has its new description, right? We can use the 2, right? And it is a positive direction. It has positive direction. We can call it 2I. And the unit, because here I has any unit, we need to define the unit here, right? To point out the unit is meter. So this is equal, okay? Or even 取能, okay? Equal means left hand side and right hand side, same thing. Okay. You need to maybe recognize this sign and this line put together equal to equal. What equal means? Equal means it can be replaced by the other one. Okay. Equal means left hand side, right hand side has the same terms of information. Okay. Equal 不仅仅是你计算出来后面等于算是一个 result. Okay. We draw equal here means left side, right side, same thing. Okay. Left side is a vector, right side is also a vector. Okay. Sometimes you find it's very simple, but there's full of details. I want you to catch these details throughout the class. Okay. For example, in the past test paper, I can see answer like this. So someone draw a V, okay, as the velocity, and with a arrowhead, call it a vector. Okay, doesn't matter, and equals to, okay, 12 meter per second. What is the problem? What is the problem of this answer?
Just the magnitude.
Yes, just the magnitude, because it is not equal, not equal. On the left hand side, it is a vector, right? It is a vector. At the right hand side, it is just a scalar, right? You just have a scale, just have the magnitude. You need to point out the direction. You need to point out direction something, maybe 45 degrees, right, to the horizontal. And this is the complete answer. Otherwise, there will be a 2-point marks deduction. Okay, don't forget to point out the direction, because direction is very important. 非常重要，对吧？那往南边，你买机票，你去一个地方，那 direction 不对的话，当然你可以飞到那边，对吧？你想去澳洲，你可以绕北极，你也可以直接往南走，right? But it is a waste of money if you go another direction, right? Direction is very important. Okay, so continue for this 4 meter to the left hand side. We can write it like this. 4, right? It's negative I, right? Negative I. And meter, right? Oh, sorry, a negative 4. Not a negative 4. Sorry, 4 to the left, right? 4 to the left means 4 negative I. Finally, it's not simple enough, right? Sometimes we do not tend to write a bracket here. Yeah, just as he said, we can put this minus sign out. It's negative 4I meter. Okay. So when you see negative 4I, it does not mean there is a negative displacement. Okay. The displacement are all positive. The magnitude always positive. This negative sign belongs to I. Okay, this negative sign belongs to I. It's equivalent to 4 negative I. Okay. Okay, this is I. And similarly, we can have J, right? We can have also K. So we have I, we also have J and negative J. And we have same thing with above to above, and the only difference is Y, from X to Y. And we also have K and negative K. K is about axis C. Okay, it's a J is something related to positive Y, and negative J is something related to negative Y, and K is something, right, the direction positive Z, and negative K is negative Z. So now for I, J, K, and X, Y, Z, we have their own unit bases here. There's no need to remember, just use it. And you will learn how to manipulate or how to operate such a kind of basis, because we will use it time after time. Okay. 接下来你要熟悉我们新的这个叫什么 vector language. Okay. This vector language. Why we emphasize vector? A very famous dynamics lecture called Beer. Okay, and his textbook named vector mechanics. Okay, so he put the vector, the word, on the textbook's title, which emphasizes the importance of vector method. Okay, it's very important to use vector to analyze. Why we need to use vector? Because what we talk about is all about magnitude, not only magnitude, but also direction. We need to consider the direction. Therefore, we need to use vectors. Okay, and then since we have displacement and velocity and accelerations are easy to define. So for velocity, we firstly define the average velocity. Average velocity given a time interval, given a displacement, right? So the displacement, this is the displacement over time interval. Displacement over time, we got a velocity. Remember, it is a velocity. It's not speed. Speed is us, right? S-P-E-E-D. 它是速度啊，它不是速度。Velocity. When you see velocity, it means direction and magnitude. Okay? Because displacement contains direction, right? Displacement contains direction and magnitude. It has two terms. Therefore, over time is a scalar, right? It just has a value, right? No direction. And after such a division, we got a velocity, also a vector with the direction and magnitude. And based on that, okay, move forward, we can define instant velocity. So what is the instant velocity or instantaneous velocity? It is the limit, okay? So V, the instant velocity, is limit delta t to 0, a very, very small time interval, delta s over delta t. And at such a condition, the calculus rules, right? The rules of differentiation, or the definition of derivative tell us we can denote it as ds over dt. Actually, in handwriting, we can use s hat to denote this is a vector. Therefore, when we see the left-hand side and the right-hand side, they are all vectors. They are all vectors.
Calling the load will be your ES.
咩事？
即係咪
你知唔知 D 係咩事？
differentiation？
係啦，跟住咧，唔係差唔多，一點都不能差的，這個差一點，它只是一個符號的約定。Okay, it's a definition. In mathematics, okay, let's recall mathematics. In mathematics, when you define differentiation, okay, you see f. Do you remember f prime something, right? You see f prime something. Is the definition is limit, okay, delta x to 0, right? And f x plus delta x minus f x, right? Over delta x, right? This is the definition. And f prime, not yet, okay. F prime, you can also write it as df over dt. Same thing, it's equivalent. Okay. Because when delta t, or the variable, the independent variable, okay, delta something comes to 0, and such a limit is equals to this one, okay, f prime x, same thing. We call this as instantaneous velocity. And once we got the velocity, we can have the acceleration. Acceleration, we just have derivative one more time. Okay, just the derivative of velocity. Derivative of velocity, we got acceleration, which means acceleration is derivative of velocity over derivative of over dt. Okay, fine. Here, ds over dt and dv over dt. The part I want you pay more attention is this one, dv over dt, because similar to the other vectors, v has so let me explain what makes it complicated. Okay, so v is a vector, and it is the function of t, right? T is the independent variable, time. As time goes, the velocity will change, right? It will change in two terms, two aspects. One is magnitude. Magnitude we call speed, right? It can speed up, it can slow down, right? The other aspect is direction, right? It can have a direction change. So from one point to the other point, okay, it changed in magnitude and direction. So when we analyze the change of velocity, we will consider both the magnitude and the direction. Why velocity is simple, but acceleration is a bit complex? Because velocity is when you visualize it, it's more straightforward, it's more obvious, right? If we have x and y, this is the initial point, and it is the terminal point. And we link up these 2 points. And actually, in a very short time period, right? If horizontal is dx dt, oh sorry, not dt. In this happened in a very short time period. It happened in dt, okay, and it comes from here to here. Actually, the displacement direction is same to the velocity direction, right? But for the velocity change, it can be like this, okay? At the beginning, its velocity maybe looks like this. And at the end, the velocity it looks like this. And you can see from these 2 points, you need to study the change of the velocity from their magnitude and direction. And next class we'll discuss how to study such kind of velocity. Okay? And later we will use some mathematics to get familiar with vectors. Okay, and you have 1 minute to quick read these 2 paragraphs. Okay. So what's the unit vector? Unit vector is a vector. Sometimes when we read mathematics, there are some. If it just you read it out and maybe you win, right? Unit vector is a vector. Of course, it is a vector, right? But you need to know the magnitude of this vector is 1. 1 what? 1 meter? 1 kilometer? No, it's just a 1. It is a unitless. Okay, unitless. 它没有单位的。Okay, it's not a length, not a speed, not acceleration. It's just a 1. Okay, and this allows us to give our own unit on it. Okay, unit is the other aspect of this variable. And when we see a unit vector, we just see the magnitude is 1. Okay, 1 what depends on the situation we discuss. So IJK are all unit vectors, and it's there are 3 special unit vector because I and J and K are for specific directions, X and Y and Z direction, right? But in 3D space, sorry, not just the X, Y, Z, right? The one between X and Y, how to find the unit vector? Is there a unit vector? right? So for example, ijk here, right? And if we have another one here from this is 0, 0, 0, right? To 1, 1, 1. This is also a direction. But is there a univector on this direction? Of course, we can draw it, right? We can visualize this is also a univector, right? And we call it this O and call this position as A. And we have a univector from O to A. We call it UOA, right? This green one from 0, 0, 0 to 1, 1, 1. But what this univector denote? How to denote such a univector, right? For another one, this is X, okay? This is Y, and this is C. And for the other one, we put it here, okay? And this direction, maybe along Y, it is 1. We call it position B, okay? Along Y, it is 1. Along X is 0. Along Y is 1. Along Z is 2. This is another point, right? From O to B, we have the other univector here, right? I call it a U univector from O to B, right? What is this univector be like in map, right? You see, we can have many univectors for every direction, every possible direction. There must be a univector there, right? The key point is how to find this univector. When you go to the past paper, you find the first step is to find out the univector along a specific direction. So how to find it? Firstly, here is how I do it. So firstly, we find the vector, right? Find the vector. Secondly, we make the magnitude to be 1, right? We scale it, right? Scale it, or to normalize, right? Normalize it. 让它的 magnitude 变成1。So how to scale it down, right? Or up. So first step, find vector. How to find it? It's quite easy. Let's take this one as an example, right? Find the vector. Step 1. How to find vector? OA, right? OA is that vector. See, O is the initial point. A is a terminal point, right? O is the initial point. A is a terminal point. So OA with terminal minus initial. So how to do this minus? 1 minus 0 along X is 1, right? 1 minus 0 along Y also 1, but we write in green. And 1 minus 0 in Z still 1, right? And I just write in red. And X, Y, Z. But if we just write like this, it's quite complicated, right? And we can use our IJK, right? Because 1 minus 0 along X here is along X. So we can put I here. And 1 minus 0 along Y, we can put J here. 1 minus 0 along Z, we can put K here. So finally, we have this vector is I plus J plus K, which is OA. Okay. Is it too slow for you? Do you know everything before I told it to you? Very good if you know it. And I want you to keep patient because I need to make sure everyone has the same basic knowledge. Okay, for the later discussion. Okay, it's very important. Now I have a question. So for such a vector OA, okay, we call it I plus J plus K, right? And if familiar enough, you can also write OB, right? OB is from O to B, which is J plus 2K, right? J plus 2K. We have so many vectors, and for each vector, we can find its unit vector. How to find it? First step, we need to find out the magnitude of such a vector. Magnitude. So the magnitude of OB, we just use OB without the arrowhead on it. Okay, use the Pythagoras rule. We know it is 1 square plus 2 square and square root. So it is root 5, right? And this is the OB. For OA, the magnitude is 1 square plus 1 square plus 1 square. And the square root from 2D to 3D, okay, just the generalization. It's root 3, OA. Okay, so this is the step 1, right? If we want to find the unit vector, we have step 2. Step 2, we do the normalization, right? We do the scaling. Scaling, which means the unit vector along OA is OA the vector over its magnitude. And the unit vector of OB is OB the vector over its magnitude. You name it. For every vector, you can use the same rule. Not only 3D, 4D, 5D. Okay. Just as long as in a linear space. Okay, linear space. And we call it the distance along 2 points. Okay. But in dynamics, it's just in 3D, right? No worry about high dimension spaces. But I can tell you, you can generalize it into high dimensional space in mathematics. Okay, so normalize. We just copy, right? OA is I plus J plus K over OA is root 3. So finally, you got a unit vector is 1 over root 3, right? I plus 1 over root 3 J plus 1 over root 3 K. And for OB is J plus 2K, right? J plus 2K over root 5. So which is 1 over root 5 j plus 2 over root 5 k. Right. So for any vector, you can find its unit vector. Once you have a unit vector, you have a direction. Unit vector is a servant of direction. 它就是为 direction 服务的。Okay. So later, when we talk about velocity, when we talk about acceleration, you're going to ask yourself, what is the unit vector of this direction? Because after got this unit vector, it's convenient for you to do further analysis. Okay, so in the later discussion, when you forget unit vectors, you can come back to this slide and to see what I did. Okay. This is the unit vector formula. You can verify the unit vector's magnitude. Okay. For example, we call UOB is a unit vector. First thing, it is a vector, no problem. Secondly, let's check its magnitude. Magnitude of OB, of UOB. You can check it. It is 1 over root 5 square plus 2 over root 5 square root. Simply, it is 1, right? We just come back, right? And verify. Also this one. Unit vector 嘅 magnitude 一定係1。如果唔係1，佢冇 unit vector。Okay, this is the unit vector formula, and later are some examples, and for you to calculate. Right? But I give you the answer here, right? But you can still have a try for yourself. Do you need a break? Okay. 10 minutes break. Okay, let's move on. Now we have a very powerful mathematical tool. We call it a unit vector. So later, no matter what kind of variable we're gonna calculate, we just use the unit vector to denote it. So for example, So unit vector. So how to use it? For example, the displacement, right? The displacement delta S we have discussed before. It can be something maybe 2I, right? And 2I meter. And this is the vector, right? And this is for displacement. For a velocity, for example, maybe velocity at a specific point, right? At a point A, okay? So it can be maybe 3J, okay? It means the magnitude is 3 and the direction is J, right? And the unit is a meter per second, different, right? So as you can see, if the unit is not given, okay, if the unit is not given, you cannot tell whether it is a velocity or displacement, right? As long as we give it a unit, we can know what it is. We can also have a acceleration, right? Maybe acceleration at point A, maybe it is 5, okay? It is 5, and its unit is meter per second square, meter per second square, because it is a second order derivative over time, right? About time, and not enough. This is the magnitude, right? This is the magnitude, and this is the unit, and we have the last piece, which is the unit vector. And for the unit vector, it can be any unit vector here to show any acceleration. For example, we can put 1 over root 5 I plus 2 over root 5 J. Although we put some number here, we do not change the magnitude, right? We do not change the magnitude. This is the unit vector. So for each amount, for each variable, it has 3 parts. First part, magnitude. Second part, direction. Third part, unit. Okay, 3 pieces of information. You will consider this, right? Sometimes every single natural, even the unit, and we just experience everything unconscious. So, but when you come to another different environment, a different condition, and you will be unit sensitive. One time I went abroad to have a conference, and on Google Map I saw another place. Okay, just 2, for example, it's just 2, and I thought it was a kilometer. And when I walk there, because I know what 2 kilometers mean to me, but at last I recognized it was miles. Yeah, it because at that time I was starving, And yeah, after come to the destination, I was exhausted. So I remember those things. And so also in our dynamics, okay, when you talk about something, you're gonna be unit sensitive. Okay, you need to consider the unit because, for example, an airplane, maybe to the 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 takeoff speed, right? You can maybe it is in maybe kilometer per hour or in meter per second, right? And there is a scaling between them, right? 3.6. So maybe in kilometer per hour, it is a very good speed. But in same number, but in meter per second, maybe the speed is too high, right? So we need to be unit sensitive. Okay. Yeah. To consolidate this part, and let's verify one fact, which is that the unit vector do not influence the magnitude. So you see, for this acceleration, it is, you can call it as 5 meter per second square, 5 meter per second square as the magnitude. Doesn't matter. Why we can neglect the magnitude from the unit vector? We can neglect these numbers when we talk about the magnitude. Actually, it is still 5. When we calculate, and we experience like this: 5 1 over root 5, right, times square plus 5 2 over root 5 square, right, and the square root. You find what? I highlight this part from the unit vector. So it can be 5, right? 5 square, right? We put them apart, right? Times 1 over root 5 square plus 2 over root 5 square. And the later part is 1. So square of 5 and root. So at last we have 5, still 5, right? So the unit vector is nothing to do with the magnitude, because the unit vector's magnitude is 1. It's just a indicator of direction. Okay, so just remember, unit vector, a unit vector is just a direction indicator. Just a direction indicator. It has nothing to do with the magnitude. Okay, so much for the unit vectors. And I just leave it to you for after class practice. And you know we have a very important skill here. So for any variable, we can just use its magnitude come as a unit vector to denote it. And you can read the direction and the magnitude in such a expression. Okay, let's put it into use for to get familiar with this description. We know at this condition, point A is something is a ball, right? And kicked from point A, and it has a 10 meter per second magnitude, right? VA, 10 meter per second, showing the picture. And this velocity is it's 30 degree, right? From the horizontal. Horizontal is X, right? Horizontal is X, and the vertical is Y. And how to use the I and J to denote such a velocity? in your mind, it must be a VA equals to magnitude times its unit vector, maybe UA, right? Times its unit vector. And then you have a unit, right? Meter per second. So the key point here is find the unit vector. Why it is important? Because when given a angle, can you find out the unit vector linked to this angle? Actually, as I repeated a lot of times, it's for me, it's not hard because we just write VA is 10 root 3 over 2 I plus 1 over 2 J meter per second. Okay, I can just write it unconsciously. But I tell you the process, how to get this number. Why we have such a combination. So when you look at this angle along x and y, when you see this vector, we know this is the unit vector, right? We know this is the unit vector. And if it is a unit vector, we know the magnitude is 1, right? Magnitude is 1. Unitless, just 1, right? And let me zoom in, okay? The magnitude is 1. And horizontally along x and vertically along y, right? Here. So for this unit vector, it is the summation of two vectors. We call it the row of parallelogram or the row of a triangle. So how to do it? Actually, along x, this is x, right? And this is y. This is y. Along x, we do a projection. It has a projection to the x-axis. By projection, this is a right angle. Same thing. We have a projection onto y-axis. This is also a right angle. So we got two right angle triangle, right? This one and this one. Horizontally, this is the hypotenuse and this is the adjacent. So from the hypotenuse to the adjacent, we use cosine, right? Because this is 1, then horizontally the length here or the magnitude here is 1 times cosine 30 degrees. Okay. And when you know this is 1 times cosine 30 degrees and the other one must be 1 times sine 30 degrees. Because this age is same to this one, right? So this is the opposite. I mean, this age is the opposite to this angle. For the opposite age, we use sine, right? So finally, we have 1 times cosine 30i plus 1 times sine 30j, both positive. Therefore, when you use calculator, this one is cosine 30i. This one is sine 30j. I show you every detail in it. And next time when you find an angle, you need to know how to find out the unit vector. Any question? 这个应该没问题。You have tried it in your middle school, right? So simple. No problem, right? Okay. Now this is the answer. So let's follow our solution here. Okay. So we just copy and paste. Okay. Copy here. And paste here. And hey, how to paste? Let's just repeat it. This is 10, right? Root 3 over 2i plus 1 over 2j meter per second. So then you can expand it. So v is 10 times root 3 over 2i plus 10 1 over 2j and meter per second. Finally, you can calculate the right both of them, and finally you can got the answer like this. So when you read this this vector, you can see intuitively, you can read something from it. Although you cannot tell the accurate angle when you just see such a number, but you can see 8.67 is a bit large than 5, right? It means along I direction, it is larger. Along J direction, it is smaller, right? It means this direction is closer to X, right? Closer to X. So it can help you to simply check your answer. Okay. Sometimes a velocity, okay, in the diagram, it looks like this, but you got a larger y when compared to X, and you need to double check your process. Okay. So by this ratio, you can see the angle. Okay. Approximately closer to X or Y. Okay, and yeah, the last one, link up the direction and the vector is the ratio. So sometimes when you read the textbook, or some conditions. Okay, for example, given a road, if this is a road and there is a slope on this road, and this slope, it just give you 3 numbers on this slope, and it do not give you such an angle. And we can find out the angle by ourselves, right? We can find out the angle by ourselves based on this right angle triangle. Because you can see in this slope, horizontal component is 4. Vertical component is 3. Naturally, hypotenuse is 5, right? 3, 4, 5 is very, very common number group. So how to use it to find out the vector, the unit vector? Actually, it's quite easy. You just if you want a unit vector here, actually at last what we need is a unit vector perpendicular to this one, right? And on this slope, along this slope, we have a unit vector here, right? And but what we want is a vector perpendicular to this one, because we need to point out VB. We need to point out VB. So we can, okay, we can just use the later one, and we can do it like this. So we can draw a similar triangle. We can do a similar right angle triangle, right? So what make the similarity? So hypotenuse, this one is perpendicular to this one, right? And for 2 legs, this one is perpendicular to this one. At last, this one is perpendicular to this one, right? So these two triangle are similar to each other. So as we can have the similar ratio here, right? So the ratio is this one is longer leg is 4, it's shorter leg is 3, hypotenuse is 5. We have such a ratio. So we can write this this vector based on a coordinate system. We just give it here, right? The coordinate system is here. So horizontal is the x to the right, and the vertical is a y, right? So in this angle, we can use the addition of vectors. We can do it like this. So we start from here. It's the initial position, right? And finally, we got the terminal position here, right? So from the initial to the terminal, we have a vector here. We want to know this vector, right? We want to know this vector. To come to the terminal, we're gonna have 2 steps, from initial to a middle point vertically, right? To the middle point vertically. And then second step, from middle point to the terminal horizontally, right? So we can do it in 2 steps. What we want is this vector, right? This vector, we call it any vector. We just call it a lambda, okay? It's a Greek letter, lambda, okay? So lambda is from initial to terminal, right? lambda is from initial to terminal is 5 something, right? And it is first step, initial to midpoint. Okay, initial to midpoint is 4. 4 is in y direction, so we have 4j. And second step, from middle to terminal is 3. 3 because it moves negative to the axis, x-axis, right? So opposite to x positive. So it is negative I. So this is lambda. And once we got this this value, what do we want? Is a unit vector. Unit vector, we know the magnitude of lambda. Lambda magnitude is 5, right? You can verify, right? 4 square plus 3 square and the square root, right? So 4 square plus square 3 square and the root. It must be 5, right? Therefore, the unit vector of lambda here must be 4 over 5. Oh, we put an I in front of j, okay? It must be 3 over 5 negative I plus 4 over 5 j. This is the unit vector finally we got. The addition of vectors, you just link them up from the initial point to the terminal point, one by one. You can even swap it. One more. This one. Right? Still 3, 4, 5, right? And horizontal, horizontal is 4. Vertical is 3, right? What we want to know is this direction, right? This direction, first step, we got the, in this triangle, we take it into 2 steps, horizontal and vertical step, okay? So from the initial to the terminal, right? Horizontally, vertically, 2 steps, right? Horizontal is 4i, vertical is 3j. So finally, we have this red vector, we call it R, okay, for red, is 4i plus 3j, right? We got the vector. And next step, we just normalize it, right? So R, the unit vector of R, we call it UR, is 4 over 5 I plus 3 over 5 J. Put 2 examples together, you can compare them. Once you got the ratio, you got the vector of that variable. It can be used for velocity, can also be acceleration, even angular velocity, even angular acceleration. So you need one more step. I give you 1 minute. You just write down for this one what VA is. For this one, what VB is. You have the you have the answer at the next slide, but I want you to feel this process. Finish this process by yourself. VA. We write a vector here. So at the right side, it is 3 pieces of information. The magnitude read it from here, 150. Okay. Direction is from the unit vector here. Okay. So 150 times the unit vector, and then the unit. Retard. So at last is 150. Okay, this is the magnitude. Then the direction, 4/5I plus 3/5J. And then the unit. You can even expand it. Okay, you can even expand it. VA is 120, right? I plus 90J in a meter per second. For VB, you do the same thing, right? VB, it is 20 meters per second, right? 20 meter per second. And then the direction. Direction is just over here. Use a unit vector, negative 3/5I plus 4/5J. So finally, you can expand it. VB is 20/5 is 4, right? 4 times 3 is 12. So negative 12I plus 16J, right? Meter per second. What we gonna use is this one or this one. And this part or this part is a preparation of this number, this stage. Okay. Once we got the vector of the amount, vector of variable, we can do the further analysis. Before here, everything we put in preparation, right? We will prepare for such a variable for further calculation. This answer and the practice, and yeah. Actually, I don't tend to move on in the first class. Okay. And but we can have a preview about what we're gonna talk. Okay, let's summarize. So after this, we're gonna have a map. So we learn the keyword of this lecture is univector. Univector. And we know we can use it to describe different variables. We can use it for displacement, right? Displacement or velocity or acceleration. Actually, even more, because in later lectures, we'll talk about angular displacement, angular velocity, and angular acceleration. So in the next stage, when you see Greek letters with vector, and it must a variable for a rigid body. Rigid body. It's not for a particle. And these amount are for particles. All right, these are for particle. But for rigid body, we did not study or learn it yet, right? And how to link them up? How to link them up is the motion of a rigid body, right? The rotation and translation theory. And mainly it is about rotation, because translation is simple and you can know that later. So for unit vector, you can transfer from a angle, right? And you can transfer from a ratio, right? For example, give you 4, 3, 5, and you can got this unit vector. In the other example, if give you a angle, right? Give you define a coordinate system and give you angle 30 degree, you can get the unit vector. Also, give you 2 points, right? Give you a pair of points, 2 points. I mean, the initial point and the terminal point, right? Give the initial point and the terminal point. You can find the vector, right? You can find the vector by the subtraction of this point's coordinate. And then you can find the unit vector along this direction, right? So based on those, you can find out a unit vector and use this unit vector to describe the dynamic variables. Okay, dynamics variables. So we should be familiar with this way to describe a dynamic variable. And I give you a lot of practice for this. And so as I told before, once we know IJK, right, and the representation of a particle's motion, and we were curious, maybe you're not curious, about the rotation of a rigid body. I mean, the motion of a rigid body. It's not a particle anymore. For a particle, it has no volume. 它是没有体积的, no size, right? Just a point. So we cannot see this particle rotate something, right? But for a rigid body, it is a set of particles, right? And we put them together, and there's no deformation. We call it a rigid body. Rigid means no deformation. So for such a rigid body, it can turn, right? It can turn. It can rotate about a specific axis. In such a rotation, if we want to learn it, we need to clearly describe how it rotates. Similar to a particle, we have angular something. So you see, For a particle, we have velocity, we have displacement, right? Displacement. And we have velocity, right? We have velocity. And we have acceleration. But for a rigid body, it's not a particle anymore, right? And when we talk about its rotation, we call it not just the displacement, we call it angular displacement. And we call it angular velocity. And angular acceleration. What is angular? Angular means the angle change. Okay. Something turns from 0 angle to 90 degree. So we call it maybe a counterclockwise 90 degree displacement, right? Now the direction becomes clockwise or counterclockwise or anti-clockwise, same thing, right? And the magnitude becomes the angle in degree or in radian, right? RAD, or in revolution, right? How many rev it has. So we have specific letters or symbols for those variables. For displacement of particle, normally we use R. Velocity, normally we use V. Acceleration, normally we use A. Okay? Latin letter. Okay? But for angular something, different. Angular displacement, we use theta. Angular velocity, we use omega. And angular acceleration, we use alpha. Greek letters. Okay. So the question is, when we know omega or alpha or theta on a rigid body, and then given a position of a specific particle, we need to calculate, we need to know V or alpha of a specific position, specific particle. Why it is important? Why it is important? Where is the end? Okay, let's. Why it is important? If we have bus, and we have bus, okay, it right to the right side, and we have passengers at a different position, right? Once it turns, we need to consider the acceleration of passengers from different positions to make sure everyone can bear the acceleration, right? Can feel comfortable. So we need to, when we know the motion of a rigid body, and we need to specify the motion of the specific particles on it. Even more, when we know the motion of one rigid body, we need to know the motion of another rigid body linked to this one. We have too many mechanical mechanism. But to summarize, there are about 4 types. First one, we have one rigid body right here. We have a link here, right? This link can rotate about its end. We have another link here, okay, rotate about this end. And we can use a rod to link them up. This is the first one. We call it a 4-bar linkage because we have 1, 2, 3, 4 bars, right? So 4-bar linkage. The other one is the combination of rotation and linear motion. For example, we have a link that can rotate about this center. And then we have a slider. We have a slider that can slide along its own rack. And we can link them up so that if this one rotates and this slider will slide along its rack. Right? And slider moves back and forth, and as the roller rotate, we call it a crank slider. The third one is a bit simple. So we have one rack. We have the other rack. Oh, sorry. Other rack. And we have one slider moves along this rack. We have the other slider moves along this rack. And if we use a rod to connect these 2 sliders, we call it a double slider. The last one is typical one is rolling. So when we have a wheel, right? When we have a wheel, we put it on the road. It rolls. This rolling is also a combination of 2 movements. Firstly, it rotates about its center. Secondly, it moves forward, right? So when we talk about, when we discuss the motion from particle for a rigid body, typically we learn these 4 cases. In the following lectures, 3 to 4 lectures, we will analyze the motion of these 4 types of structures. For example, we know how it rotates. For example, we know its angular velocity, angular acceleration. At this position, can we find the angular acceleration of this one? Right? Or angular velocity of this one? Can we find the velocity of this specific point? It's very important because when you design a mechanism and you can plan its path, right? Later, I can find some YouTube videos for you for this. For example, if you design such a structure and you can move it further, right? And to have maybe something here, right? And you can plan this path, design this path. When we know the structure's dimension, you can calculate at a specific position what is the velocity and acceleration of this particle. And the motion of such a particle comes from the rigid bodies, right? So also, for a crank slider, it can transfer the linear motion to rotation, right? So it is widely used in the engine, right? Because the piston has a linear motion, and the output of the energy, right? And we need to transfer to rotation. So when you know the piston's velocity, can you calculate the angular velocity of the piston of the roller, right? For the double slider, we have flexible mechanisms for specific utilization. For example, in construction, right? And we can use such a double slider to act as a plotter to plot sphere or other specific shapes. For the rolling, also widely used, right? Where we have some pulley, where we have some cars, right? And train, right? Wheels are used everywhere. And the question is, once we know the angular acceleration or angular velocity of such a wheel, can you find out specific points acceleration and velocity? If you can respond to those questions in a very short time, you can get a full mark in your midterm test. Actually, we just record the midterm test. I just put out those cases and let you to discuss the specific position, let you to discuss, and or find out a specific point's velocity or specific object's angular velocity or angular acceleration through relative motion. So you can see for every motion in the rigid body, actually, we can just divide it into two parts. One is rotation, the other, nothing more. It's just the rotation plus translation. So firstly, we learn how to process rotation, how to deal with the rotation problems. So next lecture, we will talk about the rotations with the vector method. The translation is quite simple when you experience rotation. So at last, you can use it into this structural analysis. Yeah, that's it. I hope to see you all in the following lectures, okay? Let's keep a very high attendance rate.